Okay, so this one is on dividing fractions, I think. So let's get to it. If I find it. Yeah, here we go. So, just a little review here, how we divided fractions in our class. We didn't use, we didn't multiply by the reciprocal, or as some of you know it as keep, change, flip, but instead we changed both fractions so that they shared the same denominator. Okay, and then we divided. Okay, so there's a little on the top here, right here. If you don't remember, you can look at it. Okay, review. So let's do the first one. Maybe by doing it, you can remember. So here's 4/3, 3/4 divided by 1/3. All right, so, and I'm gonna draw it. So here is something cut into fourth, and it means that I have this much, 3/4. Right? Should I use a different color? And then here's something cut into thirds. Right? It's a little bit different. So how much is this divided by this? So how many times can 1/3 fit into 3/4? A little bit difficult, right? Because this piece right here is a little bit bigger than the 1/4, so you can't really tell exactly how many times this fits in here. So the idea here is to make everything the same. So let's change this. So 3/4 divided by third. Let's find the LCM. The LCM is 12. So the 4 here multiplied by 3 became 12, and I'm going to multiply the same on top. It's 9. So 3/4 and 9/12 are exactly their equivalent fractions. Okay, I just changed it to a denominator of 12. So the 1/3, how do I change that to something that has a denominator of 12? This was multiplied by 4 to become 12, so I'm going to multiply the top by 4, so that becomes 4/12. Now I'm going to draw this and show you how much easier it is to picture this. So here is something cut into 12s, hopefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what I'm going to do, I'm going to, I can, I can't, I can, no, so I'm going to duplicate, there we go. Come on, move it. Not you, the other one. Okay, maybe not. Alright, okay, got it. I'm gonna do it I was gonna just duplicate it. So, trying to do the same exact thing as best as I can. Okay, same exact one. So this one was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Again, cut into 12s. So here, I'm going to shade 12. Right? And here, I'm going to shade 4. 1, 2, 3, 4. Now notice that the size, these sizes are exactly the same. See, these are all cut into 1/12. This is 1/12. 1/12. They're all them 1/12 pieces, and so are the bottom. So this is 1, 2, 3, 4/12s right here, right? This is 4/12s. How many times can 4/12s fit inside? Well, it can fit. Show you, fit one time, right? These 4/12s can fit in here one time, and another group of 4 2 times. So now I have this group of 4/12s fit in there 2 times, and I'm going to try to fit these 4 inside here, but I can't fit all 4 of them, but I can fit how many of them? I can fit 1 out of the how many that I was trying to put in there? 4. So this is my answer, 2 and 1/4. So let me prove it now doing it this way. 9/12 divided by 4/12. Our denominators are the same. When the denominators are the same, our units are the same. We can just cross it out. And rewrite this 9/4 as 9 over 4. 9 divided by 4, written as a fraction, is 9 over 4, same thing. And if I change 9/4 to a mixed number, guess what it becomes? 4 goes into 9 2 times. How many left over? 1 over 4. Okay. Okay. So again, 5 6. I'll draw it out. 1 2 3 4 5 6. Okay, very ugly 5 6. But out of the 5 6, I have this much. Okay. 5 6. That's how much of it I would have. Now, and then something, same size, but half. How many times can this half fit in here? I can't tell. Okay, I know for sure once and a little bit more, but that's not how I want you to find the answer, by guessing what that little bit more would be. For sure one time, this half would fit inside this one time, and then some change. So instead of guessing, let's change this problem. Our LCM is 6, right? That's already a 6, so now it changes. How did the 2 become a 6? Times 3, and I change the top and multiply by 3. So 1/2, another way of saying 1/2 is 3 over 6, right? Look how easier our problem's going to become. So let me try to draw that again. 1, 2, 3, 4, 5, 6, and I'm going to draw the same exact one. 1, 2, 3, 4, 5, 6. And now I'm going to shade 6 on the top, and I shade 3 at, 5 at the bottom. Sorry, 5, 6 is 5, and 3 at the bottom. So, how many times can this group of 3 here fit inside here? Well, this could fit in there. That can fit in there because they're the same size, right? And this can also fit in there. So definitely fits one time. So I'm going to try to fit, now I take these 3 and fit it over here. Well, it's going to fit once, right? That can go there one time. This can go there, right? But this, there's no room to fit on the other. So out of the 3 that I'm trying to fit, I'm able to fit 2 more out of the how many? 3. Here, our denominators are the same. Cross them out. Let's write 5/3. 5 divided by 3 as a fraction. 5 and 3. Change that to a mixed number. 3 goes into 5 one time. How many left over? 2 out of 3. So whether you do it this way or using pictures, you get the same answer. Okay? But it's much easier to figure out your division problem when our bar here is divided into the same amount, okay, in 6 or in fifths. Here, one was divided in 6, the other one was divided in halves. Here, both are divided into 6s, which makes our life much easier. Okay. Okay, again, so the same thing. I want to change this. So the LCM is 8. Right? So that's 7 8. 4 3/8 multiplied by 2, multiplied by 2. So 6 8. Cross out, it becomes 7 over 6. Or if you change this, 6 goes to 7 one time, 1 left over, another 6. I'm going to draw it out. I'm going to draw the second one out. Here's something that has 8 pieces, hopefully. 1, 2, 3, 4, 5, 6, 7, 8. Something that has 8 pieces again. 1, 2, 3, 4, 5, 6, 7, 8. So on the top, I had 7 pieces, right? So here I have 7 8, and at the bottom I have 6 8. How many times can 6 8s fit into 7 8? Well, that can fit in there, right? So let me see. That can fit in here. Fit in here, fit in here, fit in here, fit in here, fit in here. So that group of 6 fit in there one time. And now I'm going to take that group of 6 and try to fit it in this last one over here. But only one of them can go in. So 1 out of how many I'm trying to put in? 6. So how many times can this 6 fit into the 7? One time. And if you try again, you can successfully fit one more in out of the 6. So there's the same answer. When it's a whole number, put it over 1. Right? So what's the LCM between 1 and 3? It's 3. That stays the same. This changes to 3 times 3 at the bottom, so times 3 at the top, which is 15 over 3. 15 over 3 divided by 2/3. Let me draw this out. Do I want to draw this out? All right, fine. It's 3's, right? Okay, 1. So 15 over 3 would look, okay, please imagine them all being the same size, exactly the same. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is what 15 over 3 looks like. Oh, shoot. Okay. This is 15 over 3. So that's 1/3, 2/3, 3/3, and then this one over here would be 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, 12/3, 13/3, 14/3, 15/3. So total of 15/3. So 15/3, and 2/3 looks like this, right? The same box. And instead of shading all of them, you only have 2/3. So how many groups now? These two, right? How many times can these two fit in here? Well, it fits once, fits 2 times, fits 3 times, it fits 4 times, it fits 5 times, it fits 6 times, it fits 7 times for sure. Then if these two, can these two fit in there? No, but one of them can out of the 2 of yours, so 7.5. Let's see if you get the same answer. 15 over 3 divided by 2/3. Cross the 3's out. Let's write that as a fraction, so you get 15 over 2. And that gives you 7.5. And then we have one more. 4/5 divided by 1/3, same thing. We want to change that to a whole number. So you get 4/5 divided by something as a fifth again. So you're going to change times 5, and that's times 5. This is 15 over 5 now. Alright, so here's what 4/5 looks like. 1, 2, 3, 4, 5. 4/5 look like that. Shoot. Okay, no idea what's going on. 4, 5, and I'm going to do 4/5. 1, 2, 3, 4. That's what you have. 4/5 of a chocolate bar, 4/5 of something, and you want 15 over 5. Okay, so 15 over 5 would be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 15 over 5 is all these columns, right? 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, 10/5, 11/5, 12/5, 13/5, 14/5, 15/5. How many times? So the question is, how many times can these fit inside here? Man, you can't put all these 15 inside here. So out of the 15, how many can you put inside? Well, you can put this guy over here, this one in this place, this guy in here, and this guy in here, and that's it. You were able to successfully put 4 out of the how many we're trying? 15. That's it. That's your answer. So again, on this side, let's see how we do this. We cross the 5s here. We write 4 divided by 15 as a fraction. No, voila, you get the same answer. Last one. She has 9/10 cup of sugar. Each batch of cookies require 1/4 cup of sugar. How many batches of cookies does she have? So use a modifier as well as doing as much. This means divide. Oh, okay, so 9/10 divided by 1/4, because that's how many you have. You want to cut it up into 1/4. So how many times can 1/4 go into 9/10? LCM is 20, right? So 9/10 written as a denominator 20 is times 2 gives you 18 times 5 times 5. So it becomes 18 over 20 divided by 5 over 20. Okay, we didn't change the problem, we just make sure that we change it to equivalent fractions where they share the denominators. I'm going to continue this. Got to cross the 20s out because they're the same. So we got 18 over 5 And as a mixed number, you can 5 goes into 18 3 times. 3 left over 5. So 3 batches, 3 full batches of cookies, and 3/5 of another one. They also want you to do a model. Ugh. Okay, you don't want to do a model of this. You want to do a model of this once you find out the denominators. Okay, so let's make something that has 20. Yikes. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, 13, 14, 15, 16, 17, 18, 19, and there's my 20. I'm going to do another one. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and there's my 20. So on the top one, you have 18, so all the way except the last two. That's how much sugar you have. And 1, 2, 3, 4, 5, and that's how much you need to make one batch of cookies. Here is what you, so 1, 2, 3, 4, 5, up to here makes one batch. So 5 of these makes one batch of cookies. So let's see, 1, 2, 3, 4, 5. That's one batch of cookie. 1, 2, 3, 4, 5. That's a second batch of cookies. 1, 2, 3, 4, 5. There's a third batch of cookies that you can make. And I'm going to try to put this again here, and you can only put 1, 2, 3. So 3 batch of cookies for sure. And if you try to fit this 5 into these 3 spots, you're only going to be able to put 3 of them out of the how many you were trying to put in. And you were trying to put in 5, 3 and 3/4, and you get the same answer as this one. Okay, hopefully that helped. Review.